guys. I got more requests, and I'm gonna do a grade 12 paper. I've realized I kind of do the same problem, so I'm gonna try and divide the problems up better. I think this is paper 2. I'm not sure. We'll check. I got requests to do statistics, so that is very dependent on how you use the calculator, and so I will try to do a demonstration on how you can approach the statistics, mode, all those stats, and input the data, and you get your regression and all those things. So yeah, but let's just jump into these two questions. I probably did a new thing. I think I have never done Euclidean geometry in this channel before, so yeah, that's really fun. That is the second question. So I'm gonna try jumping as fast as I can to make this a bit fast, but also try explain everything that you need to know. So we have a question here. It says in the diagram, line OP is given. P has coordinates -3, -4. Angle KOP equals to A. And then determine without a calculator. Oh, my favorite words. The value of that. So to do this, I actually like approaching this in a very different way. Probably not how you were taught, but tell me if this method works. Yes. So I don't know if your teachers would have taught you this method, but if they didn't, so yeah. So you have this, right? And this is angle A right here. So actually, let me use a different color. This right here is angle A. I'm gonna say angle, and we have coordinates -3 and -4. And if you want to get the hypotenuse, so this is point P. If you want to get the hypotenuse, we're gonna use Pythagoras theory. So we're gonna name this C, and then you just have to state what C is. So let OP equal to C. The reason I like doing that is just I don't like using OP like variance, because it's sometimes you do it so much and then it starts confusing you. It's like EDDFFE, like kind of things. So putting them as variants like ABC, XYZ, all those things is nicer than putting them as yeah. So I'm gonna say C squared, or you can name it R. Maybe it's probably best if you do it R. Why not? It doesn't really matter. It's just we're naming a variable. We're not really just whatever variable you name it, just keep that variable in mind. So this is then equals to -3 squared minus y squared minus 4 squared, which r squared equals to 9 plus 16, where r equals to plus or minus 5, because this is equals to 25, and then r for OP equals to 5, and the reason is length. So we have that. We have our r or OP equals to 5, so we can write 5 there. What I like to do is that I know that angle A is in the third quadrant. So remember our quadrants are, this is the first, this is the first, second, third, and then fourth quadrant, and this is our cast graph. So I'm kind of gonna change the color. Oh my god, yellow. I do want the yellow. Yeah. So I'm gonna C. It's gross yellow. C A is T. And what do we know about angle A? So this is nice that I'm not confusing those two A's. I know that angle A is in the third quadrant. So I'm going to take that advantage and I'm going to name my angle here. I'm going to name it Yeah, so the second question is, I am kind of sad because I wasn't recording. So I have a lot of things here and I just saw that the recording cut off. So I need to get better practices at being a YouTuber. So what doing the second question of 5 point. Don't forget to label your questions, guys. That's really important. So they say determine cost 2a. We don't usually do this in the channel, but I am actually gonna use the information sheet from the back of the paper, so you can just rip it off and you don't need to memorize these things. I think the only time you would not use this, but you can still use it, but not use this, is when you're proving an identity. Like when they ask you to prove that 2a is equal to that. Other than that, you don't need to do this. So I'm just gonna copy it. Equals to 2 cos squared a minus 1. And if I hide that, should have that. And I have cos a, so 2 times minus 3 over 5 squared minus 1. That is 25. 18 over 25 minus 25 over 25. Because we're not using a calculator, I'm gonna have that. And then the last question says that if sine a minus b is that, and sine b is 4 over 5, and b is in, this is the second and this is the third, I mean fourth quadrant, so it's between those, so it's definitely not in the first. And we know that sine is positive on the first and the second, so the fact that sine is positive here, it means that triangle exists in the second quadrant. So they're saying determine sine a if sine a minus b, if sine b equals to this, and that is probably really easy to determine. So actually gonna, it's 5, that is gonna be 4, and we know that that is gonna be minus 3, but we want to write that down, that minus 3 exists. So since I've already done it, I am just gonna erase the parts that were not supposed to have been already done. I am terrible at recording, guys. So let's do that. So we have everything here. Let's determine if it's actually minus 3. So we're gonna have, I'm gonna call it, since this was R, let's call this C now. This one equals to C. And then we're gonna have c squared equals to x squared plus y squared, and that is Pythagoras. We're looking for x squared, so we're gonna have x squared equals to c squared minus y squared. We're looking for x, we can just go with that. Then equal to plus or minus root of that, and plus or minus 5 squared minus 4 squared, which is plus or minus 3, and then we know that it is minus 3, and the reason it is minus 3, so we're saying therefore x equals to minus 3, and then it's second quadrant. So we have that. So we did prove that it's minus 3. Now we're gonna have sine a minus b equal to, let's check the information sheet. I know you guys already know most of the identities anyway, but it's really nice to check on your information sheet what it actually equals to. Let's sine A cos B, sorry, now I'm writing it like how they wrote it, minus cos A sine B. We have cos A, we have sine B, but we don't have this, and sine A would be opposite over hypotenuse, so minus 4 over 5 times will be minus 3. Cos B would be minus 3 over 5 minus cos A is minus 3 over 5, and then sine B we can just copy it from there, or so, and we know this is 12 over 25 plus 12 over 25, which is 24 over 25. We can leave it like that. So yeah, and let's jump into the second 5.2. So 5.2 we're kind of going to do in a different way, so I'm going to show you two methods on how to do it. The first method is don't do it, and then the second method is how I would actually do it if I was in the exam. So what I'm going to show you is not really on your information sheet, so that's why I'm saying probably don't do it. Also, kind of memorizing things could be not a good thing, so yeah. But if you just wanted to learn something new and awesome, this is a nice way to do it. So we're gonna do half angle identities. Half angle identities state that sine of theta over 2 equals to plus or minus square root of cos minus theta all over 2. Cos of theta over 2 equals to plus or minus square root of 1 plus cos theta over 2, and tangent of theta over 2 equals to sine of theta over 1 plus cos 2, or equal to 1 minus cos theta over sine theta, right? So knowing these half angle identities, we can easily do this one. So what I'm gonna do is convert this into half angles. I know that alpha over 2 minus 45, I'm gonna say this would be minus 45 minus alpha over 2, and I'm gonna take out half there, which then equal to half of 90 minus alpha over 2. So if I let theta equal to 90 degrees minus alpha over 2, I'm gonna then have alpha over 2 minus 45 equals to minus half theta, and I can substitute that. So cos of alpha over 2, so let me just write my problem here. Alpha over 2 minus 45 degrees sine of alpha over 2 minus 45 degrees all over 2, and this would equal to cos of minus theta over 2 sine of minus theta over 2 all over 2, which equal to cos of half theta over 2, that's just cos theta, so the negative angle, it's just us having the Cartesian plane, and then instead of it going this way, it goes that way, and we know in this quadrant cos is positive and sine is negative, so we know that this would be cos theta over 2 times minus sine theta over 2 all over 2. So having this, we're gonna go to then the identity pack and have minus plus or minus root of 1 plus cos theta over 2 multiplied by, so it's plus or minus, so it will be plus or minus, so 1 minus cos theta over 2, and I'm just gonna do it because it's all over 2. Okay, I can write it there, all over 2, and that equal to minus plus or minus root of 1 minus cos squared theta all over, now root 2, and then it will be 4, and then it would equal to minus square root, this will be sine squared, and then it will be plus or minus sine theta over 4, right? Sine theta over 4, well, we're given cos alpha, right? And then what is theta? Theta equals to plus and minus sine of 90 degrees minus alpha. So sorry, this was supposed to be just alpha. Minus alpha. Imagine if I didn't catch that. All over 4, and 90 degrees minus alpha changes to cos, so minus plus or minus cos alpha over 4, which is minus or plus p over 4. So to figure out if this positive or negative, it's really simple. It is negative, only because we just assume that theta is in the first quadrant, so it's between 0 and 90, and then we're like, oh, okay, then if it's between 0 and 90, then it's going to be carry the first one, so it's going to be negative. I would go into how we assume this, but it's going to take up a lot of time of explaining identities and stuff, and I'm like, I don't want the YouTube video to be 50 minutes. So yeah, other than that, we can go with the normal way where we have our information sheet as a guideline, and I just see this. So knowing that, I could so I could write it out as alpha over 2 minus 45 degrees would equal to minus 45 minus alpha over 2, which equal to minus half of 90 minus alpha, and I can say then that theta equal to 90 degrees minus alpha, right? that's what theta equals to. So this would be cos of minus theta over 2 times sine of minus theta over 2 all over 2, and I'm gonna multiply by 1, where I'm gonna put it as 2 over 2. So now I'll have 2 cos, okay, well, let's just write minus. So I have equal to minus 2 sine theta over 2 cos theta over 2 all over 4, and we know this is sine 2 theta, so we have minus half of sine, no, actually sine 2 times theta over 2, so sine theta over 4, and that equals to minus sine of 90 degrees minus alpha over 4, which equals to cos minus cos alpha over 4, which equals to minus p over 4. So yeah, so this is list steps. It's a great intuition to have when you see cos, sine, and the same angle. So half theta, to try and go to 2, especially seeing it halved is like, my first intuition was to do that, was like, oh, I need to make sure this is kind of double, and seeing 45 was 90, and yeah, so great way to approach this problem. Great problem, actually. Tell me if you want to do more of half angles. Yeah, so this question is a Euclidean geometry question, and like I said, I don't think we've actually ever done Euclidean geometry, so I'm gonna try and incorporate more and more of the problems we haven't done in the channel, and try and do that, So provide reasons for question 9, 10, and 11. This is so nice. They never did that for us. But yeah, the reason they say that is any Euclidean geometry problem, you will probably have to state the reason. Once you state something, you probably have to state the reason. If you say this equals to 10, you probably say, look, it's equals to 10 because I don't know. So you need to learn for these problems. Euclidean geometry depends on the theorems. I think there's 9 theorems. I am not sure. It's been quite long for me to. It's been a long time, but yeah, you just need to learn the theorems. I think every theorem expands on the next theorem. So if you're down with the theorems, like the kids say, I'm just kidding, then you would know how to solve these problems. So yeah, let's just jump right in. It says in the diagram is ABCD as a cyclic quadrilateral. BC is produced to E, so BC is produced to E. AC is drawn. AC is drawn. A1 equals to half of B. A2 equals to 46. C1 equals to 86. Calculate with reason. They just always remind you that don't forget your reason, because I think those carry marks. The value of A1. So in a cyclic quadrilateral, something like this, what I already see is a external interior angle of a cyclic quadrilateral, where this angle equals to that baby right there. There's also other theorems, like if AC was the diameter, this would be that, all those. So just remember your theorems, practice them. I don't think they're provided. Yeah, they're not provided in the information sheet, unfortunately. the word would be strange, but yeah. So just know your theorems, and we know that C1 equals to angle DAB. So I'm gonna write with reason. So I'm gonna go angle C1 is equal to angle DAB, and the reason is exterior interior angle of cyclic quad. Actually, that's kind of so I can have space to do the other stuff. Oh my god, I'm not the most artistic person. Can say like, oh, she's being WhatsApp by Photoshop. So if we have that, then we know that angle A1 plus angle A2 equals to angle C1, which is 86 degrees, and then angle A1 would be equal to 86 degrees minus A2 is 46 degrees. Therefore, A1 would equal to 40 degrees. Nice. So 9.2, hence prove that AD equals to BC. So if we prove that this side equals to that side, that's an isosceles. It's best we prove these because we have angles and we don't have anything about length. To prove that, we would have to calculate angle C2 and show that angle C2 equals to angle A1. To do that, we need angle, there's a lot of ways we can approach this. We kind of need angle C3 and angle B. So to get angle angle B equals to angle A, which equals to 80 degrees, right? And then angle A2 plus angle B plus angle C3 equals to 180 degrees. And the reason for that is sum of angles of triangle equals to 180 degrees. So angle A2 is 46 plus 80 plus C3 would equal to 180 degrees. Sometimes I have the inclination of saying Celsius. C3 equal to 180 minus 46 minus 80 degrees. So C3 equals to, that is 100 minus that is 54. I just don't have a calculator next to me. It's not even about not want. I just don't have one next to me. So angle C1 plus angle C2 plus angle C3 would equal to 180, and then sum of angles on straight line equal to 180. So we're coming for C2, so C2 equals to 180 degrees minus C3 is 54, then C1 is 86, so C2 would equal to 40 degrees. because this is 90, 140, 40 degrees, and we have A1 equals to C2 equals to 40 degrees. Therefore, AD equals to DC. Isosceles triangle. I don't know, so we're gonna go since A1 equals to A2 equals to that. This implies that AD equals to DC, and then we say isosceles triangle. Or you can just do a triangle and do this. I am not sure. I'll probably do this too. So yeah, that's really fun. 4 marks. This is a lot for 4 marks. They're really stingy with marks in this department, aren't they? So yeah, hopefully this helps. I will do more Euclidean geometry problems. But yeah, bye guys. And subscribe and hit the bell. Yeah.